So this question says that we have several different cans of different sizes and shapes, all filled with the same liquid to the same depth. So I'm going to have a big fat can, I'm going to have a little skinny can, I'm going to have a weird shaped volume can, I'm going to have the opposite one, but I'm going to fill them all to the same depth. And it wants to figure out which one of the following equation or what following statements is true. Well, let's look at them one by one. First one says that the weight of the liquid in all the cans is the same. Well, this is a small area. They all have the same density, right? They all have the same density of rho. This volume right here is a much smaller volume than that volume, which means this can weighs a lot less than that can does because of the liquid in it. The force on the bottom of each can is the same. Now, I'm not quite sure on that one, but I think I can reason this one out using Newton's second law. The bottom of the can, or the water itself, let's say the liquid itself, let's draw a free body diagram for that. Well, it's going to have its weight force pulling down, which in this case is rho times the volume of the liquid times g. And pushing up on it is going to be a normal force from the can. So I'm just treating the liquid as one unit. Well, if it has a larger weight force and it's not moving, and meaning it is in equilibrium, then the larger weight force is going to mean that there's going to be a larger normal force pushing up on it. So the force of the liquid on the bottom of the can is the same. That one I don't think is right because the larger the mass, the larger that weight force is going to be. So this normal force pushing up on it, it's what the can pushes on the liquid. The liquid pushes on the can with the same amount by Newton's third law. So this one's going to have a much larger force than that one. The pressure on the bottom of the can is largest the least pressure is at the bottom of the can with the largest area, or the greatest pressure is at the bottom of the can with the largest area. I'm going to say both of these are wrong because I know that as I go down in depth, the pressure is equal to the density of the fluid times gravity times the height that I travel down. And since all of them have the same height that they change, they're going to have the same pressure. It doesn't matter their shape, but the force per unit area on the bottom of all four of these different cans, or any can that you can think of, is going to be the same. They have the same density of the liquid, they have the same gravity, and they're at the same depth. That's what our problem says. So it's a little bit of a confusing problem, but not that bad if we just remember some simple physics and just knowing that the depth of the liquid determines its pressure. Of course, always there's the density and gravity, but in this case, the depth is the biggest, our biggest factor, the one that we're really most interested in for this problem.